Dear students, today we will discuss about cardinal points of an optical system. In last class we have discussed introduction of that cardinal points and what are the cardinal points. So what is the cardinal points here? An optical system consists of a thick lens or number of lenses kept in a contact having 6 important points are called as cardinal points. It means already have discussed these things, that is using thin lens we can find very easily those parameters, that is height of the object and then height of the image, and as well as the distance of object and then distance of the image from the optical system. So all these things we can find very easily by using the methods. But instead of taking only one single lens, we are going to take a several number of the lenses, and then for all these lenses we have to find the height of the image and then object and then the distance, how it is refracting. All these things we can find, but for finding all these things we have to find those parameters for each lenses what the refraction will take place, and then finally we will get that refraction from final this surface. So this is a very difficult to find all these parameters. For this problem the Gauss was invented, or find out the solution to using the cardinal points. Those cardinal points are 2 focal points and 2 principal points and then 2 nodal points. So in this optical system we are going to use one of the thick lens, that is with considering that lens is a thickness D, and then this is the incident surface and then this is the refracting surface. So now here first we will see that is 2 focal points and 2 focal planes. So let us take now here one thin lens. We can take a thin lens or a thick lens anyway, and then now for finding that focal points. Now here this is the principal axis passing through the center of the that convex lens. You can take convex lens or a concave lens. So now this principal axis is will give the name for A and A dash. The point at which ray is incident on the lens after refraction produces a parallel beam of light. See here, this is the one point I will consider on the principal axis. From that principal axis, from that point I will take a one incident ray, it is incident on the first surface and then refracted from the second surface as a parallel to that principal axis. And then now here this point is called as F1 focal point, and then this is a image formation where it is that is infinite. That image is formed at infinite distance, and then another one of the ray we will take, that is that incident ray is parallel to the principal axis, and then after incident on the first plane it is refracted through the second plane, and then it meets that refraction light is meets the principal axis. This point is called as second focal point. So now here F1 and F2 are the focal points. F1 and F2 are the focal points, focal point 1 and focal point 2. These 2 points F1 and F2 are called as principal foci. These 2 points are called as principal foci, or it is called as focal points, or it is called as focal points. The plane is passing through the focal points perpendicular to the principal axis. Plane is passing through the focal points perpendicular to the principal axis. These planes are called as a focal planes. These planes are called as focal planes. Now, distance from, see here, this is the center of the lens. The distance from the center of the lens to the F1, that is called as first focal length, and the distance from the center of the lens to the F2, that is called as second focal length. So now what are the focal points here? These are the 2 focal points. One is a F1 and another one is a F2. So, and then what are the focal planes here? The which line is passing through the that focal points perpendicular to the principal axis, that is called as focal planes. This is a first focal plane and this is a second focal plane. And now we will see the second one, that is, see here I have taken a one small graphical representation or a ray diagram. Say this is a point on a principal axis, this is incident point, and then next what happens? These are the number of the incident rays are incident on the first surface and then refracted parallel to the principal axis, and here the image is infinite. So similarly, second one, that is the number of the incident rays are parallel to the principal axis, incident on the first surface, refracting through the second surface, and then all the rays are converging at the single point, that is called as F2. Okay. Now we'll move to the second one, that is the principal point and then principal plane. So here what will happen? We will take a thick lens. And then we'll draw one principal axis on the thick lens, and see here I have taken, we'll draw neatly here. This is the one surface, incident surface, and this is the second second surface, that is refracting surface. So now here this is the principal axis. So first I will take one of the ray from the point. This is the one ray incident on the first surface and refracted inside the that surface, and then next emerging from the outer surface. Okay, and then next another one ray we will take here. This is the incident ray parallel to the principal axis and refracting inside the that lens, and then refracted or emerging from the that outer surface, and then meeting a point on the principal axis. So this is the F1 and this is the F2. Okay, now here what we'll do, we'll give the name for each point. This is a S, and then this is a T, and then this is a W, and then here this is a R, and we'll take here this is a Q, and then this is a P. So all these are incident and then refracted rays. So now here what we will do, we will extend this incident ray as a parallel to the principal axis, and then it joins that refraction of the ray which is from the F1, and now we will increase this F1 S ray. Okay, and then next again what we will do here, which is the refracted ray of the PQ is there, will increase in the backward direction. Okay. Now what will happen here, this ray and then this incident ray is cuts each other, and then here also this refracted ray cuts at the one point. We'll draw one perpendicular line passing through those points which is cuts at each other and then on the principal axis, and then what we will get, that plane is cuts that principal axis in both case. Here also will cuts the principal axis. So at this point is called as P1, and then this point is called as P2. This point is called as first principal point, and this point is called as second principal point. And then this plane passing through that points perpendicular to the principal axis, those planes are called as first principal plane and second principal plane. Second principal. This is the scenario of this ray diagram. So let us now see here the explanation of this diagram. Consider a thick lens. This is a thick lens or a coaxial refracting surface having the principal points F1 and F2, F1 and F2. A ray PQ, this ray PQ is incident on the first surface and then emerging out from the second surface, that is RF2. That is RF2. R appears to be intersection of H2. A plane passing through the H2 and perpendicular to the axis in terms as second principal plane of the lens, it point the intersection, whatever this intersection is there, that is nothing but the second principal point. So and next similarly another one of the ray is passing from the first principal point, first focal point, and then incident from the first surface, incident surface, and then next emerging out from the second surface TW. This emerging ray is meet at H1. A plane perpendicular to the axis passing through the H1 is called as first principal plane. This is called as a first principal plane. The point intersection P1 with the axis is called as first principal point. So here these two incident rays are directed towards this one and this one. These two are directed towards H1, and then these two emergent rays are directed towards H2. Thus H1 and H2 are conjugate points, and the plane H1 P1 and H2 P2 are pair of conjugate planes. So therefore H2 P2 is equals to the H1 P1. So whatever the lateral magnification is there for these planes, that is always 1. That is always 1. So here what we have studied, so two incident rays are there, and then we will get the two refracted rays, and then from these two incident rays we will get one intersection of the plane, that is h1, and then here h2 will get. From that h1 and h2 will find the p1 and p2. These p1 and p2 are the principal points, and then h1 and h2 are the principal planes.